This conference will now be recorded.
In today's session, we'll try to understand one more important service which is in AWS, that is RDS. So we'll understand what is RDS, what are the advantages or features we will have with RDS, why we need to use RDS, and also the various types of RDS instances. So the RDS stands for Relational Database Service. So database as a service is offered by AWS, that is RDS. So first of all, I hope everyone know what is database, right? So let's understand what is database first. Later, we will understand RDS. If you take any application, any typical three-tier architecture, you have a presentation tier, you have an application tier, you have a database tier. So presentation tier is basically GUI. Presentation tier is basically GUI, the graphical user interface, using HTML, CSS, React.js, jQuery, Angular. Using these type of technologies, using these type of frameworks, we can develop the presentation tier, that is GUI, whatever has been presented to the customers. If you see, if you take any application, any web application, if you take any web application, a dynamic web application, it has a presentation tier. If you take this as an example, this is presentation tier, whatever has been presented to the customers. So these presentation tiers can be developed using programmatic technologies like JavaScript, HTML, CSS, bootstrapping, React, Angular, like that. These presentation tier internally communicate with application tier, APIs, application programming interfaces. So this presentation tier will receive take the input, and this input will be passed to the application tier, APIs. Those APIs can be developed using some programmatic languages like Java, Python, Node.js, Go language, or .NET. And those application code and presentation code can be hosted in a application servers like Tomcat, if it is a Java-based application, and WebLogic, WebSphere. If it is a .NET programmatic language has been used, IIS server, or Node.js, Node server, or Python servers. We can host that application and presentation into the application servers. But that applications will internally communicate with the database tier, data tier. That is where the data is actually persisted. The applications will persist, update, and retrieve the data from database, data tiers. There are again different types of databases. One is RDBMS, that we call it as a SQL databases. RDBMS are basically SQL databases. SQL databases, SQL databases. Example for this, you have MySQL, you have Oracle, Microsoft SQL Server, and you have something called IBM DB2 or Postgres, MariaDB, IBM DB2, like a databases, MySQL, SQL databases, or RDBMS, Relational Database Management Systems. And we have something called non-SQL databases, NoSQL databases, document-oriented databases, So document-oriented databases are JSON format, they are going to maintain the data. Example for these NoSQL databases, we have MongoDB, We have post this couch base, right? Couch base, Cassandra, etc. Cassandra, etc. So these are basically a database. So relational database, RDBMS. A relational database is a way of structuring the information, maintaining the information in a tables and rows and columns. And you can establish the relationships between information by joining the tables. Like let's take an example. Let's take Flipkart as an example. Let's take Flipkart as an example. In Flipkart, you can create a orders, right? Flipkart may have a customers. Flipkart will have customers. Flipkart will, that customers may place the orders. So in RDBMS, you can create a tables and a rows in the table and a columns to maintain the data, like customer information. Just to give an example, Flipkart has a lot of customers. So what is the customer ID? What is the name of the customer? What is the billing address for that customer? What is the shipping address for that customer? So customer table, you can create some table where you can maintain some information like customers information. If you take Flipkart as an example, and if you take customers may have orders, customer may have orders, what is the order ID, and that order is created by which customer, a relation. So customer may have a relationship with orders, right? So order ID, which customer placed that order, when the order is made, what is the order status, whether it is delivered or not, whether it is still there, when it is shipped. All these informations can be maintained in a relational databases in a tables, rows, columns format. So these two tables are related, and there is a relationship between that customers and orders. If you need a report, suppose if you need a report as a branch manager, as a Flipkart customer care manager, if he need a report, he can generate the reports about all the customers who made purchased orders on specific date, like that. So databases, relational databases is a way of maintaining information in a tables, rows, columns, and a relational database will establish a links or relationship between by joining the tables, which makes easy to understand the relationship between various entities, various data, like customer to orders relation, like that. There are various database systems, database softwares, as I told, MySQL, MySQL Server, Oracle, PostgreSQL, MariaDB, IBM DB2, like this. You have various databases. So this is relational database. Relational database. Before cloud came into picture also, before any cloud came to picture like AWS, Azure or GCP, any cloud came into picture into existence, also we used to have these tables, this relational database softwares. So if you are having your own data center, if you are having your own data center, you are using your own data center, let's forget about cloud, you are not having any cloud, you are not using cloud infrastructure. If you run, if you have your own data center, right, if you run a database in your own data center, on-premise data center, you have a server, you buy one on-premise server. If you are using on-premise data center, if you want to set up the database in your own data center servers, you buy an on-premise server, you buy a one physical machine. So you will get a CPU, memory, storage together, and you may probably, you may hire a database administrator. You may hire a database administrator. Your dbs will run the databases. Your dbs will set up the database on the servers that you are owning in your own data center. The database administrator is responsible for installing the database software and maintenance, security patches, taking the regular backups, and so on. So if you are using your own data center, you have your own on-prem server, you are going to purchase one server. On top of that server, you are going to set up a database software, whatever you need to use as a DBA. They are responsible for installing, applying the maintenance, taking the backups, doing the security patches. So it's a lot of intensive process. It's a lot of manual process, lot of labor intensive process. But without cloud, without cloud, this is how you do things. Without cloud, this is how we do things. So for relational database, if you want to set up in your own on-premise environment, you fulfill your responsibility of the server, operating system, and software. You need to responsible for everything. Suppose you have your own data center, on-premise environment, you want to set up your database. Are you responsible for purchasing the hardware and maintaining in the data center also? Power, network, cooling system to your data center and your hardware, server maintenance, OS installation, OS patching, database installation, database patching, database backups, and you need to make sure your database are highly available, scalable. So if you are using on-premise environment, you are responsible for all these things, for managing the databases, database servers, the database softwares. Is everyone clear? Before cloud came into picture, if we guys are using our own data center, what is the responsibilities we have to take care in our data center to set up the database? Everything you need to take care. We need to take care everything. Clear on this first point? In your own data center also you can run a database like MySQL, Oracle, MongoDB, PostgreSQL, like that. Is everyone clear on that point? How we used to do the things in our own data center when we are using a database in our own database server? Now, lately, people started using cloud. People started using cloud. People started using cloud. Amazon or basically AWS or Azure or GCP or whatever it is. In Azure, you have one service called EC2. In Azure, we have one service called EC2. Right? What is that EC2? We already discussed. What is that EC2? Is it a virtual machine in the AWS data centers which we can create and configure whatever softwares which is required on that EC2? Yes. So EC2 provides scalable computing capacity. EC2 provides scalable computing capacity in the AWS cloud. So EC2 eliminates investing in a hardware setup. If you are using EC2, do I need to worry about these things? Power, network, cooling system, purchasing the servers and maintaining the hardware? No. So this who will take care if I am using EC2? AWS. AWS. So EC2 eliminates investment in hardware upfront, so you can develop and deploy applications faster. So if required, can I set up a database on EC2 instances? I can create whatever type of EC2 instance. The way I have installed Tomcat, the way I have installed Jenkins, can I install database softwares like MySQL, MySQL Server, Oracle, Postgres, MariaDB, or whatever it is like this? In EC2, on top of EC2? Yes. On top of EC2, we can do that. But for a database on EC2 instance, AWS manages the below OS, below the layers of the operating system. AWS manages this one. But if I am setting up a database in EC2, again, do I need to take care about OS installation, operating system patching, database installation, database patching, database backups, again availability, replication in the database, scalability in the database. In the database also you have a concept called replication, primary DB, secondary DB, standby DBs. If I use EC2 also for setting up the database, am I responsible for all these things above this hardware? Again, if I use EC2 also to set up the database on top of EC2 directly? Yes. So for a database on Amazon EC2 instance, AWS manages the layers below operating system. In this way, AWS eliminates some burden. AWS eliminates some burden. Only this hardware burden AWS eliminated. But still, if I try to run database on top of EC2, do I need to manage these things also? Yes. So EC2, it's not a fully managed service. EC2, it's not a fully managed service. When you run a database on Amazon EC2, you are more prone to the user errors. If you run database on EC2, you are more prone to the user errors. EC2 is not a fully managed service. For example, when you update our operating system or when you update a database software manually, you might accidentally cause issues in your database. Again, you might spend checking hours of time to identify the issue and fix. And again, you need to make sure your database replications is done. You need to make sure your database primary, secondary setup is done. You need to take care of the backups, everything, even though you are using EC2 to set up the database. Is everyone clear? On top of EC2 also you can run your database software, but you are responsible for all these things to set up and manage the database, that RDBMS. Clear? Then what is this RDS? Then what is this RDS? So RDS, it's a fully managed database service. RDS is a fully managed database service. If I go with RDS, does all these things will be taken care by AWS only? OS installation for database instances, OS patching, database software installation, database software patching, database backups, scaling the databases automatically, making sure there is a primary, secondary databases, that replication in the database. Is everything will be taken care by AWS only? If I go with RDS directly, instead of configuring database on my own on top of EC2, if I go for RDS, RDS is a managed database service. RDS is a managed database service. It is responsible for most of the management task. It is responsible for most of the management task, like provisioning database instances. You no need to create instances for the database to set up. Who is going to provision the servers in the background for your database to set up? AWS. And who is going to take care about all the management activities like provisioning, replication, database replication and database backups? In real time, there is a problem with single database server. Again, if you are managing a single database server, if that primary DB goes down, do you have any secondary DB to make that primary? Like that, if you have a single database, no. So instead of you set up that replication, who is going to set up the replication architecture for the database, like primary DB, secondary DB, read replicas, all those things? AWS. And the backups, you no need to worry about the backups. RDS will take the backups and maintenance updates, all those things, by eliminating most of the manual task. Is RDS is eliminating most of the burden from us to manage the relational databases in cloud? Is RDS is eliminating most of the burden from us, like all these things? Only application optimization you are responsible. Optimization in the sense, you are using a database RDS, but developers is going to develop the code. So developers will connect to the this RDS instances, but if they not properly write the queries, procedures or functions, it may take some time. That optimizing the database performance, is customer has to manage. Like when you create a database RDBMS, this RDS services, you have various types. Again, various types, storage types, instance type. You need to select as per your requirement to optimize the performance of your database. Except this one, is everything is taken care by AWS only. Yes. So we recommend Amazon RDS. We recommend Amazon RDS over database on EC2. Instead of installing database on top of EC2 directly, we recommend RDS because most of the database deployments activities will be taken care by cloud only. So is everyone clear RDS? What is RDS? RDS is a managed database as a service, that relational databases as a service. Most of the management task will be taken care by the provider, that CSP itself. Is everyone clear? What is RDS? It's a managed database. It's a managed database as a service. Now, as I already told, right, most of the things will be taken care by the provider only if I go with RDS. So it's a managed database. What are the features of, what are the advantages of RDS? What are the advantages of RDS? You can use the database products. You can use these database products. We can use the database products. You are already familiar with MariaDB. You are already familiar, right? You can use already the databases products you are already familiar with, like MariaDB, MySQL Server, or MySQL, Oracle, Postgres, all these things. Navin Tulsi is asking, in Kubernetes we use image there for database. Can we use this RDS? Don't relate anything with here Kubernetes. Don't bring the concept. Kubernetes is completely different. Kubernetes is a container orchestration software. You can run any software as a container. In fact, you can run database also as a container. Don't bring Kubernetes concepts here, okay? Database also you can run as a container, but I am not. This RDS is a service directly. RDS is a database as a service. So instead of you set up the database servers, or instead of you deploy the database in Kubernetes, database is separate cluster that is managed by RDS. So don't bring Kubernetes here. Kubernetes is different. RDS is different. So instead of you set up the database in Kubernetes by deploying your database software as a pods, as a containers, you can use RDS. Everything will be taken care by AWS. Simple. It's up to you whether you want to use RDS or whether you want to manage your database on your own EC2, or you want to run your database on your own way also, like a containers or virtualized. But if I go with RDS, is most of the things will be taken care by AWS only. You no need to set up the database software. You no need to install database backups. You no need to worry about it. But if you go with database on Kubernetes, you can run database software as a pods, as a container. But are you responsible for deploying those database pods? Are you responsible again for replication, scalability, backups? Yes. So don't relate with this Kubernetes. This is completely different service. First of all, don't bring other topics here, because my focus, I don't want to deviate. My focus is only Terraform, AWS. Okay. If you are already familiar, understand. Don't ask me to again explain Kubernetes, Jenkins, all those things. So you can use database products which you guys are already familiar, like MySQL Server, Oracle, PostgreSQL, all those things. So Amazon RDS manages the backups. You no need to worry about the backup. You no need to worry about the storage. Storage is also scalable. Backups will be automatically taken by RDS, and the software patching, automatic failure detection and recovery. If there is a database failure, that RDS instance is failed, automatically it will recover and it will detect the failure, and it will replace that database like with another database like that. And you can create automated backups. You can create an automated backups, or you can manually create a backups of that RDBMS, this RDS instances, right? If something goes wrong, you can restore your database again with the backups, and you will get a high availability. You will get a high availability with primary instance, and also a synchronous secondary instance also will be created. A secondary instance also will be created, and the database replication will happen automatically. If any issue happens with primary database, automatically the secondary becomes primary. There is a failover. In the background. There is a primary DB. All these things will be taken care by RDS only. There is a primary DB. The data will be synchronously updated into the secondary. If something goes wrong with primary, this guy will become a primary. You no need to worry about that failover. In the background, automatically the RDS service will take care. And in addition to the security in our database, you also have a control. Who can access your RDS instances, your database instances. So you can control access to your RDS service using IAM, and also this RDS instances, you are going to create in a VPC, a private network, in which you can create your AWS resources. So can I create in my own network if required in a private subnets, and also there is a firewalls which I can attach to the RDS, where I can allow what systems can talk to these databases. So you have a full control on the networking also. So is everyone clear what is RDS and what is the futures of RDS? Now in RDS, in relational database as a service, we will call some terminology. We have some terminologies. We call it as a DB engines, the RDS components, the components of RDS, DB engine. A DB engine is a specific relational database software. DB engine is nothing but a specific relational database software that runs on your database instance. RDS is currently supporting following database engines. RDS is supporting MariaDB. RDS is supporting Microsoft SQL Server, MySQL, Oracle, PostgreSQL. So DB engine is nothing but DB engine is the specific relational database software that runs on your database instance. RDS is currently supporting following database engines, database softwares: MariaDB, Microsoft SQL Server, MySQL, Oracle, PostgreSQL, like that. So database instance class, database instance class, database instance class, database instance class determines the computing and memory capacity of your RDS instances. Database instance class determines the computation, the computing power, the computing CPU and memory capacity of your database instance, right? So database instance class is nothing but it is going to determine the hardware capacity of your database instances, computation and memory capacity. And a database instance class consists of both the database instance type and size. Like each type offers a different compute, a different memory, different storage capabilities. The way we have a instance types in EC2, right? The way you have an instance type in EC2, similarly this instance class is nothing but the capacity, the computing and memory capacity of the database is based on the database instance class. And again, each instance type offers different compute, different memory, different storage capabilities. And instance storage, database instance storage. This RDS instances in the background, it is going to use EBS values. these RDS instances. You are not creating the database instances. RDS is creating the database instances in the background. That RDS instances internally use EBS value. So that instance storage, internally it will use EBS, block level storage values that you can attach to the database instances. Internally, these database instances are managed by RDS, and it can support general purpose SSD values, provisioned IOPS values, magnetic values also like that. But as I already told, if you need a better performance in your RDS when you are reading and writing the data, which storage gives better IOPS, low latencies? We already discussed in AWS EBS. We already discussed all these things in AWS EBS. Which one will give the low latency and high IOPS? SSD only. SSD only instead of general purpose. Instead of general purpose, if you go with provisioned IOPS, you will give more IOPS, right? So internally, internally, these database instances are using values, these EBS values. I think I told, right, how many IOPS, minimum IOPS, maximum IOPS per second per GB. In EBS, we discussed all these things. Just I think one week back, guys. Did you guys recollect, remember? 1 week back only I discussed. So this database instances also will use EBS values in the background. You can select whatever type of your choice. The storage type differs in a performance and characteristics and price. So you can use whatever storage of choice, your choice. And each database has a minimum maximum storage requirements depending on the storage type. And it is very important that you have to have a sufficient storage so that your RDS instances can use that to store the data. And again, this RDS supports auto scaling of the storage. Even though when you created RDS, you selected 20 GB. If the 20 GB is completely utilized by RDS instances, can it grow automatically instead of you manually increase the disk size like that? Yes. So auto scaling of the storage is also there in RDS. But if I go with normal EC2, do I need to manage the storage? Do I need to scale the storage again? The way I need to install database also, I need to manage the storage if I go with EC2. Okay. So this RDS internally uses VPC. This RDS internally uses VPC. This RDS internally uses VPC. You can run RDS instances in a virtual private cloud VPC. So when you use a VPC, you have a complete control on your networking, right? So you can choose your own IP address range, you can create a subnets, and you can configure the route tables and access controls in VPC. So when you create a RDS in a specific VPC, do you have a complete control? If you are creating RDS in a private subnet, does that RDS can be accessed from public internets or from different networks? If you create a RDS in a private subnets in your VPC, can you access that RDS from a different servers, application servers which are deployed in a different VPC or in your from internet? Guys, VPC concepts. Just 2 days back only we discussed. 3 days back we discussed, right? What is VPC? What is subnets? Public subnet, private subnet. I am asking one question. If I create a RDS instances in a private, that RDS in a private subnet, can we access the database from application servers which are hosted in a different networks or from internet? Can you reach the database instances to insert or update or create the data? No. So you have a complete control. You have a complete control on the networking. Complete control on the networking. So the basic functionality of RDS is same whether it's a running in a VPC or not. RDS manages the backups, softwares, patching, automatic failure detection, recovery. So there is no additional cost to run your database instances in a VPC. And security. How I can secure my RDS? How I can secure my RDS? RDS has a security group. RDS has a firewall. That RDS has a firewall also. So a security group controls the access to the RDS, the database instance. So can I allow what source of IPs can be connected to that RDS endpoint, that RDS servers? Yes. And also service perspective. Using IAM also, can I control who can delete RDS, who can update RDS, who can create RDS using IAM concept again? Yes. So you can use identity and access management to grant access to the RDS, who can create RDS, who can delete RDS, who can update RDS clusters like that. So is everyone clear? The components, what do you mean by database engine? What do you mean by database instance class, instance storage? With respect to RDS, what is VPC? In VPC only you are going to create a RDS, and that RDS has a security group also. Is everyone clear the components of RDS? Now when you create a RDS, I will demonstrate that each RDS will get a endpoint. Endpoint is nothing but URL, basically domain. URL, or we call it as a domain. Does applications can use that URL, that endpoint? The applications developed in Java, Python, Node.js, or whatever programmatic language, can they use that endpoint to talk to the database? That is RDS. Yes. And when you have a primary secondary setup in the RDS, even though primary goes down, the secondary becomes primary, but endpoint remains same. You no need to worry. So in the background, AWS RDS will take care. Updating the DNS in the background will be taken care by RDS only. If the primary goes down, the endpoint IP internally, that DNS IP, the internal DNS IP will be automatically taken care by RDS. You no need to worry about. Again, if primary secondary is there, if primary goes down, secondary may become primary. But again, does the IP or the URL may change? No. So that will be internally taken care by RDS. That is what the meaning of failover. So RDS failover in the sense, you have a primary, you have a secondary, like that. So secondary is like a standby. Primary is active, secondary is standby. If the primary has some issues and primary goes down, the secondary, the standby one becomes primary, but you no need to worry about the IP change. Internally RDS will take care. That is what the meaning of failover. So do I have all these things? Failover in my databases, replication of my databases, database replication, database failover. Can I achieve all these features using RDS? Database availability, scalability, redundancy, resiliency, redundancy, all these features in the database you can achieve using RDS. But if I manage the database on EC2, do I need to take care of all these things? Database replication, database patching, database setup, database availability, scalability, resiliency, all these things? Yes. So is everyone clear what is RDS in AWS? Why we can go with RDS? What are the features of RDS? But again, it is not mandatory, right? If required, this is recommended. And strongly recommended. It is strongly recommended. You no need to worry about setting up all those things. But if you have a different architecture, You may have your own database in your on-premise environment. Then you can continue to use, and they are not ready to migrate to the cloud. They are not ready to migrate to the cloud. You can still have your own database servers which you are managing in your own data center. But the client, that client and that company is not ready to migrate to the RDS. You may still use that cloud on-premise database servers. But if they are ready to move to cloud, they are ready to move to cloud, or they're ready to use cloud, RDS is the recommended way to create and manage your databases. AWS will manage everything. You just create RDS instance, your application start using that RDS instance. Clear? What is RDS? Now, as I already told, you have this concept internally. As I already told, internally, RDS will use regions and availability zones concept again. So when you run your RDS instance, you can run your RDS instance in a several availability zones in that region. RDS is a regional level service. RDS is a regional level service. You can run database instance in a several availability zones within that region. And an option called multi-agent deployment. An option called multi-agent deployment. Multi-agent deployment is there in RDS. When you choose this option, AWS automatically provision and maintain one or more secondary standby instances. AWS will automatically provision and maintain one or more secondary standby instances in a different availability zone. This is like your master database. This is like your master database, primary database. In the background, this RDS, AWS RDS will automatically provision and maintain one or more secondary standby instances, So when applications are contacting via this RDS endpoint, all the request goes to primary only. All the requests will go to primary for write operations, and again read operations also in this model, primary only. But if something goes wrong with this primary in the background synchronously, it is going to replicate the data to the secondary. Primary in the background synchronously, it is replicating the data to the secondary. And let's assume something goes wrong with primary. Is this failover or switchover will automatically happen? You no need to worry. Yes. So automatically this failover or switchover will automatically happen. So when you create a RDS instance, you can run RDS instances in a several availability zone. There is an option called multi-agent deployment, multi-availability zone deployment. You can choose this option. When you choose this option, Amazon automatically provisions and maintains one or more standby secondary database instances in a different availability zone. Your primary database instance is replicated across availability zones to each secondary database instance. So this approach will help to provide a data redundancy and failover support. It will help you to provide data redundancy and failover support, and it will minimize the latency spikes during system backups. In a multi-agent cluster deployment, cluster deployment, the secondary database instance also serves as the read traffic. If required, you can use read operations. For read operations, you can still contact secondary also if required. So multi-agent deployment in the sense, AWS will maintain your database instances in a multiple zones. There will be a primary, there will be a standby secondaries. The primary will synchronously syncing the data to the secondary standby servers. If primary server is impacted, the standby server becomes activated automatically. The failover or the switchover will happen automatically. Is everyone clear? What do you mean by this multi-agent deployment in RDS again? If you are a database admin, you can understand how important it is to go with RDS, because the database admins knows what is the pain of maintaining and managing the databases, database resiliency, database redundancy, that failover, replication, backups, right? It's a very tedious task if you do everything on your own. But if I go with RDS, is AWS is taking all this burden from us? Yes. So the benefits of multi-agent database deployment: replication to a standby. Replicas is synchronous with highly durable. So the standby server, this primary database, will be automatically replicating the data synchronously in the background. And endpoint endpoint of the database instance remains same after failover. Arvind was asking, sir, if the primary goes down, if the standby becomes primary, does the endpoint change? No. Endpoint of the RDS remains same after failover. The application can resume database operations without any manual intervention, since the endpoint is not getting changed. Even though there is a failover in RDS, endpoint is not getting changed. So does applications can continue to use databases without any interruption, without any manual intervention and outage in the database? Yes. And it reduces the impact of maintenance. RDS performs the maintenance on the standby first. RDS perform the maintenance on standby first, promotes that standby to the primary after maintenance. So the maintenance, if you guys are doing any maintenance in multi-agent RDS deployment, first the standby server will be upgraded or patched like that. Once that patch is successfully done, the standby becomes primary, then the patching will happen in the other one. So is it going to prevent any negative impact on the backup or performance also like that? Yes. So when a problem is detected, on the primary instance, it will automatically fail over to the standby in the following conditions. When the primary database instance fail, it will fail over to the secondary automatically, that standby. And if that availability zone has a outage, in the availability zone where you have a primary, if that availability zone has a outage, the standby becomes primary. The database instance server type is changed, that time also it will fail over to the secondary. And the operating system of the database instance is undergoing some patching, then also it will become, the standby become primary. So manual failover of the database instance also can be initiated. So is everyone clear what is this multi-agent deployment of RDS? What are the advantage with the multi-agent RDS deployment? And again, there is one more architecture. Multi-agent deployment with read replicas. Multi-agent deployment with read replicas. Multi-agent deployment with read replicas. If you are using only multi-agent deployment, only this primary, this a standby. Only primary, only standby. But this standby can be there in a multiple availability zones, which means you have a multiple availability zones, right? Like 1A, 1B, 1C. So this standby can be in two availability zones, two standby database instances, one primary database instance. If this primary goes down, out of these two secondary, one guy can become a primary like that. But there is something called read replicas. So read replicas concept is little advanced concept, and again that read replicas option is not available in all the regions as of now. That read replicas concept is introduced recently, that is only available in only few regions in US. So read replicas in the sense, you have a multiple read copies, so your applications can contact, for write operations it can contact primary, for read operations it can contact read replicas. So if you are going with the read replicas approach, again, is the performance is improved because write operations will only go to the this primary. All the read operations from your applications can go to the read replicas. So is the performance is reduced? I mean to say, is the load is reduced on the primary because only write operations will go to primary, read operations will go via read replicas. So read replicas option is available only in few regions. Only in US regions they have introduced as of now. Any questions? Any queries? What is RDS? What are the features of RDS? What do you mean by this multi-aged RDS deployment? If you have any questions, any queries, let me know. Multi-aged deployment and multi-aged cluster is same. Multi-aged deployment only this one. Multi-aged deployment only this one. Multi-aged deployment is only this one. Only one standby, one master. But if you go with cluster, that multi-aged cluster, you have one primary, more secondary, that standby. That is the difference. Multi-aged like this, multi-aged cluster like this. So more than one standby servers. More than one standby servers. But if you go with multi-aged, only one primary, one secondary. Clear, Arvind? Again, that read replicas concept is introduced recently. That read replicas is different again. You have a read replicas, they have introduced recently. The secondary servers are different, read replicas are different. You have this secondary standby. Similarly, you have a read replicas. This read replicas again, who will flush the data to the read replicas again? Primary only. This primary will flush the data to the read replicas. The secondary standby servers also. The secondary standby servers is required. If this primary goes down, this secondary standby become primary. That failover will happen here. But why do we need read replicas, right? If you don't have a read replicas, read operations, write operations go to the primary only. Read operations and write operations go to the primary only. In that case, do you have some lot of load on that primary? Read operations also going to the primary DB instance. Write operations also going to the primary DB instance. Yes. But if you have a read replicas, your applications for any write operations, request goes to the that master or primary. For any read operations, it will go to the secondary. So you will get a endpoint. You will get a one more endpoint for read replicas. You are going to get a one more endpoint for read replicas. So in your application, you can use this RDS endpoint as well as read replicas endpoint. So your application will contact RDS endpoint for writing the data, updating the data, deleting the data. Your applications can contact read replicas endpoint for reading the data. But this master only, this primary only will sync the data in the background to the standby servers and read replicas also. Is everyone clear? But read replicas is recently introduced. Only in few regions that read replicas option is there. Not in all the region has this read replicas. Clear? Any questions, any queries on RDS theoretically? Let me know. Otherwise, the lab, how to create RDS instance from the management console, that is GUI. I will continue in the next class. So I'll just create one RDS instance. Okay. So Aurora DB is a different. I'll explain in the next class. Okay. First, let me explain RDS. In RDS, there is one more option called Aurora. That what is Aurora? What are the advantages in my RDS Aurora? Aurora also one option is there. So we will discuss that in the next class. But you have a lot of other features in Aurora. We will discuss that in the next class. Okay. So lab, I'll continue in the next class. Sir, suppose I initially have a database in EC2, later we have to move that into RDS. Can I create a snapshot of EC2? Can I attach that to the RDS? No, it is not like that. You need to use some kind of a migration software, database migration software. You can't detach that EC2 values and you can't attach that EC2 values to RDS instances. So there is a database migration services. Using that database migration services, you can migrate your data from your on-prem servers to the RDS, or your EC2 database servers to the RDS servers. There are some migration services. Okay, guys. Even though you guys are asking lot of so many questions, I'm trying to answer, but don't consider this is a AWS course. I am not covering AWS architect or associate architect, but instead of saying no, I am explaining whatever maximum I can answer. So this is basically, I thought of covering Terraform, but in the meantime I can explain these services also, so that you can understand what is cloud also. And again, the lab, I'll continue from here. And again, if required, I can create RDS also using Terraform. RDS also one AWS resource. Using Terraform, I can create a RDS services also. Okay. So thank you guys. I'll continue Monday. Tomorrow, no class. Try to go through all the recordings, whatever has been discussed. Try to go through all the recordings, whatever has been discussed. I will continue on Monday. Lab we will create a RDS using management console, and we will see how it works, what options we have. Thank you guys. We'll continue on Monday.